Hello students, welcome to Boundless Maths, where we make maths not just understandable but also enjoyable. So in today's video, we are going to cover definite integrals as part of class 12 CBSE Maths. In the previous video, we have already covered indefinite integrals, and now we are going to have a look at what is definite integrals. So what we have already done is we have learned how to integrate a function without any conditions, where we have the constant of integration added to every function that we integrate. So that is indefinite integrals. What is definite integrals then? When we have to integrate a function, for example this curve, and we want to integrate this function bounded by x is equal to a and this is x is equal to b, so that we get the integral of this function within this range only, then that is called definite integrals. So that means if the integral of function fx is capital Fx plus c, now we need to bound this function, integral of this function within this range. So how do we write that? The lower limit comes here, upper limit comes here. Now when we find the integral, what we do is we first replace this x with the upper limit. So we write the function, the same integrated function with x replaced by b. So that means this becomes f of b plus c. Now we subtract the same integrated function with x replaced by the lower limit, so it becomes this. And now if I open the brackets, it becomes this, and we can cancel this constant of integration. So this c and c gets cancelled. Eventually we get difference between the integrated function with the upper limit and the lower limit added to it, right? So this is called definite integrals. So let's have a look at certain questions and how do we solve them using definite integrals. For example, the first question is integral of 2 raised to power x bounded by log 2 and log 4. So what is the integral of 2 raised to power x? It is integral of 2 raised to power x is, how do we write that? So integral of 2 raised to power x, we write 2 raised to power x upon log 2, and it is bounded by the lower limit, that is log 2, and upper limit log 4. So this becomes, because log 2 is a constant, so we can take it out. So it becomes 1 upon log 2 and 2 raised to power x delimited by log 2 and log 4. So that means the answer becomes 1 upon log 2, and we have 2 raised to power log 4 minus 2 raised to power log 2. That's it. We don't need to simplify any further, right? Okay, so let's look at another question. Now in this question, as we look at this question, we can make out the first step should be to rationalize the function. Wonderful. So how do we rationalize? 0 to 1. So it is 1 upon square root of x plus 1 plus square root x. No, it is minus here. But it needs to be rationalized with square root of x plus 1 plus square root x upon square root of x plus 1 plus square root x. So in the numerator, what do we have is integral of square root of x plus 1 plus square root x, and in the denominator we have x plus 1 minus x. So that means this x gets cancelled in the denominator. Now this becomes a simple polynomial expression that we can integrate. Don't forget to put the limits. This is very important. So 0 and 1 is the upper limit, lower and upper limit, and the expression is x plus 1 plus square root of x, and we have dx. Now what is the integral of this? This is easy, right? So it becomes x plus 1 to the power of 3 by 2, and we have 2 by 3 by the side. Square root x becomes x to the power 3 by 2, and again we have 2 by 3 by the side, and the limiting values are 0 and 1. So we are first going to put the value, upper limit value in place of x in this expression. So we get 2 by 3 of, this is 1 plus 1, 2, so it is 2 to the power 3 by 2, plus 2 by 3 into 1 to the power 3 by 2, 1 to the power anything remains 1, so no change, minus the entire expression with x replaced by 0 now. So 0 plus 1 is 1, 1 to the power 3 by 2 will stay as 1, so we will only have 2 by 3 here, and this term will become 0. So this gets cancelled, 2 by 3, 2 by 3, that means the final answer is 2 into 2 to the power 3 by 2 becomes 2 to the power 5 by 2 upon 3. So this becomes your final answer. Easy? Wonderful. So let's move to the next question. The next question is integral of 1 upon square root of x square minus 16. Now in indefinite integrals we have already seen some standard formulas that can be used for integration. In this case here we are going to use one of those formulas, that is integral of 1 upon square root of x square minus a square equals log of x plus the entire radical expression as it is, x square minus a square plus constant of integration. So this is what we have already done in indefinite integrals. This is one of the standard formulas that we have already seen. So how do we use it here? The limits are 4 to 5. Integral of 1 upon square root of x square minus 4 square into dx becomes equal to log of x plus square root of x square minus 16 bounded by 4 and 5. So we will first put the upper limit, replace x with 5. So this becomes log of 5 plus square root of 25 minus 16 minus, now we put the lower limit, that is replace x with 4. So this becomes log of 4 plus 4 square is 16, 16 minus 16 here. So let's simplify further. It becomes log of 25 minus 16 is 9 and square root of 9 is 3. So 5 plus 3 becomes log 8 minus 16 minus 16 is 0. So this term becomes log of 4. So this is equal to log of 8 by 4 and that is equal to log 2. So this is the final answer. Understood? Wonderful. So let's move to the next question. It says log of 1 plus 2x dx. Now in this question we have seen in indefinite integrals that such questions need to be integrated using integration by parts. So how do we do that? There is an acronym ILATE to choose which is the first function and which is the second function, but we see only one function here. So we can write this expression as log of 1 plus 2x into 1 dx. So log function becomes the first function and 1 becomes the second function. Now we need to apply integration by parts. So how do we apply integration by parts? Integration by parts says that first function into integral of second minus integral of derivative of first function into integral of second. This is how we do that, right? So that means the first function is this, it will stay as it is, it will be log of 1 plus 2x and then we have integral of 1 dx limited by 0 and 1 minus integral of derivative of first function which is log of 1 plus 2x and then we have derivative of first function into integral of second function. So it is again 1 and then dx and put this entire expression into a bracket and then another dx because we need to integrate it once more, right? Now this becomes log of 1 plus 2x and we have integral of 1 here. So this becomes x. Now when we change it to x, we need to limit it with 0 and 1, right? Now next integral of derivative of log of 1 plus 2x is 1 upon 1 plus 2x into 2, chain rule here, right? Integral of 1 is again x limited by 0 and 1. So it is dx again because we have to integrate again. Now how do we evaluate it further? Put the upper limit as 1 here, log of 1 plus 2 into 1 becomes log of 3. So it is log 3 minus log 1 into 0. Everything is gone? Next minus, here the limits are same. We have 2x upon 1 plus 2x that we need to integrate further in the limits 0 to 1 and with respect to x. That is what we have right now. Now if you look at the second part of the question, we can use balancing here before we integrate. So this becomes 2x plus 1 upon 2x plus 1 minus 1 also in the numerator, and this can be separated out as two terms, 1 plus 2x upon 1 plus 2x, and the second term will be minus 1 upon 1 plus 2x, right. Outside we have log 3 left out because this is 0, so we just have log 3 minus, this is log 3 minus. Now we need to integrate this. This first expression becomes 1, so integral of 1 is x, and integral of 1 upon 1 plus 2x is going to be log of 1 plus 2x, so this will be minus log of 1 plus 2x whole upon 2, because the coefficient of x here is 2, and we need to limit all this with 0 to 1 also. Outside we have log 3 minus this. Now just put the value of x as 1 in this entire expression and then put the value as 0 also. So when we put 1, it becomes, the entire thing becomes log 3 minus, in the bracket we have 1 minus 2 plus 1 becomes 3, so it is log of 3, and then minus, when we put 0, it is 0 here, log of 1 plus 2 into 0 becomes log of 1. So minus into minus plus log 1. Log 1 is anyway 0, so we can just remove that. So we just have 1 minus half log 3 here. So when I open the bracket, this becomes log 3 minus 1 plus half of log 3. And log 1 is 0, so it goes away. So if I take log 3 common, 1 plus half becomes 3 by 2 of log 3. So the final answer is 3 by 2 of log 3 minus 1. So this is the final answer. Clear? Wonderful. So let's move forward. The next question is integral of x square plus 9, and the limits are 0 to 4. So in this question, again it resembles one of the standard formulas for indefinite integrals that we have already done, and the formula is when we integrate any expression of the form square root of x square plus a square, then we get x by 2 square root of x square plus a square, and then we have plus a square upon 2 log of x plus square root of x square plus a square, right. So we are going to use this standard formula here. So that means this integral becomes, here a is 3, so this becomes x by 2 square root of x square plus 9 plus a square. A square is 9 here, so it is 9 by 2 log of x plus square root of x square plus 9. Now whole thing to be delimited with 0 and 4. No constant is needed here, right. So first we replace x with 4. So this becomes 4 by 2 square root of 4 square is 16, 16 plus 9 plus 9 by 2 log of 4 plus square root of 4 square is 16, again 16 plus 9, then minus, and the entire expression with every x replaced by 0. So this first term becomes 0 because it is x by 2, so this becomes 0, and in the second term we have 9 by 2 log of 0 plus square root of 0 plus 9, right. So let's simplify it first. 4 by 2 is only 2, 16 plus 9 is 25, and square root of 25 is 5, so 2 into 5 plus 9 by 2 log of 4 plus 16 plus 9 is 25, square root of 25 is 5, so 4 plus 5 becomes log 9, minus What do we have? Do we have anything left? 0 plus 9, square root of 9 is 3. 0 plus 3, log 3. So we have minus 9 by 2 log 3 from here, right? So the expression becomes 10 plus, we can take 9 by 2 common, and in the bracket we have log of 9 minus log 3. So this expression becomes 10 by 2 plus, sorry, there is no 10 by 2, it is only 10. So it is 10 plus 9 by 2 and then log of 9 by 3. 9 by 3 becomes only 3. So that means the final answer is 10 plus 9 by 2 log 3. So this is the final answer, right? Now there are certain questions where you need to use substitution. The way we have used substitution for indefinite integrals, here also when you see some function and the derivative of that function is also being multiplied or divided, somehow we understand that we need to substitute, or there are higher powers. So we need to use substitution here also. But the only thing that we need to take care here is when we are replacing the function with another function or another variable, some part of the function with another variable, then we need to change the limits also. This is the most common mistake that is done by many students, that they forget to change the limits. The lower and upper limit also has to be changed as per the new substituted variable, right? And rest of the things we do as we have done the previous few questions. So let's have a look at some examples. Integral of 1 upon x log x. Now this is a very important question and it has been asked in one of the board exams in previous years. So let's do these questions very carefully. 1 upon x into log x. Now here you can see that the derivative of log x is there with the function. So that means you need to put log x as, suppose, t, right? Now differentiated in both sides, what do we get? 1 by x dx equals dt. This is okay what we have done in indefinite integrals. Now what is the difference here is, you have to take care of the lower and upper limits also. So these limiting values are for x. Now what are the limiting values for the new variable t that we need to look at, right? So that means when x is, the lower limit is e. When x is e, what is the value of t? So that means if you put x as e here, so it becomes log of e equals t. So what is the value of t? Log of e. Log of e becomes equal to t, and that means t is 1 because log e is 1, so that means t is 1. So when x was e, the value of t is 1. Now what is the value of t when x is e square? When x is e square, put x as e square here, so log of e square is equal to t. So what is the value of t here now? Log of e square is t. So that means the value of log e square. So that means t becomes equal to 2 using the properties of log. So that means the lower limit changes to 1 and the upper limit changes to 2. So when we replace x with t, how we are going to write is, we have replaced the lower limit with 1, the new limit is 1, and the upper limit, the new limit is 2. Now 1 by x dx can be written as dt, so it becomes dt upon t. Now what is the integral of 1 by t? It is log t. So this becomes log t limited by 1 and 2. So this is equal to log of 2 minus log of 1. Log of 1 is 0, so that means the final answer is log 2, right? So here the only thing that we need to take care of is change the limits as per the new variable that you have substituted. Let's look at another example. Integral of e raised to power minus log x dx, and limits are 1 to 2. So here we are going to put the exponent, power of e, whatever is the exponent, we put that equal to t, right? Now what is the derivative? 1 by x dx is equal to dt. Yes? Now try to put the lower limits and upper limits and get the values of t. So lower limit is 1, that means minus log 1 is t and log 1 is 0. So this means the value of t is 0. This is the lower limit. Now if I put this as minus log of 2 as t, now what is the value of t? It is going to be minus log 2. So that means the lower limit is 0 and the upper limit is minus log 2, right? So we have just changed the lower and upper limit as per the new variable. Now what happens to the expression? It becomes e raised to power t and dx gets replaced by minus x, okay, let me write it, minus x into dt. Now this x also needs to be replaced. From this substitution, what we have written here is minus log x equal to t. This means x is equal to, x can be written as e raised to power t, right? So we replace this x also by e raised to power, it should be minus t here. So this can be written as e raised to power minus t. So this entire expression becomes integral of e raised to power t into e raised to power minus t dt. Now e raised to power t upon e raised to power t or into e raised to power minus t becomes 1. So that means it is the integral of only 1 left now. Integral of 1 dt with respect to t, and the lower limits are 0 and minus log 2. So what is the integral of 1? It is x limited by 0 minus log 2. So that means in place of x, put the upper limit first. It becomes minus log 2. I think we already had a minus sign also outside. So just take care of this minus also. So it is minus also there. So it is minus of minus log 2 and then we have minus 0. So it is 0. So that means the final answer is log 2. Right? It might seem a little complicated because there are properties of log also being used here, but this is a very important question and it is a part of the CBSE handbook also. There are lots of questions in this video. All the questions have been taken from CBSE handbook exercise 3.4. So if you solve these questions, you'll be sure you can attempt the questions of definite integrals easily. The next question is integral of e raised to power x into square root of 1 plus e raised to power x dx. Now in this question, whatever is under the radical sign, we can replace it by t. 1 plus e raised to power x is equal to t. When you differentiate, it becomes e raised to power x dx is equal to dt. Right? Now in this expression, e raised to power x dx can be replaced by dt, and 1 plus e raised to power x is only t. So that means we have square root of t dt. Now we need to take care of the limits also. The lower limit is 0 and the upper limit is 1. So when x is 0, e raised to power 0 becomes 1. This means the value of t is 1 plus 1, 2. When x is 1, the value of t is 1 plus e raised to power 1 is e only, right? So that means the new limits are, we need to integrate this entire expression using the limits 2 and 1 plus e now, right? Now what is the integral of t raised to power half? Square root of t is t raised to power half. So it is going to be t raised to power 3 by 2, 2 by 3 by the side, and the limits are 2, 1 plus e. So when we put the limits, we have 2 by 3 as constant and we have t to the power 3 by 2. So this becomes 1 plus e to the power 3 by 2 minus 2 to the power 3 by 2, right? We have replaced this variable with the upper limit and then with the lower limit. So let's simplify it further. So what is 2 raised to power 3 by 2? How do we solve this? We can't simplify the first part of the expression, but how can we solve this? We can write this as 2 cube and whole to the power 1 by 2. What is 2 cube? 8. and square root of 8. Part 1 by 2 means square root of 8. Square root of 8 is 2 root 2. So that means this second expression can be written as 2 root 2. So therefore the final answer is 2 by 3. In the brackets we have 1 plus e to the power 3 by 2 minus 2 root 2. That's it. We can't simplify it further. So this is the final answer. So again I am repeating, it's very important if you are using any kind of substitution, please change the lower and upper limits and then evaluate the integrand using the new limits. Right? So let's move to the next question. Now the next question is x upon 16 minus x to the power 4 and the limits are 0 to square root 3. So first thing is we can see that this is square of 4, so we can just change it to this form 0 to square root 3 x upon 4 square minus x to the power 4 dx. And this x to the power 4 can also be written as x square whole square. So we have x square whole square here. Now we can put x square as t, so that 2x dx becomes dt. And what about the limits? The limits were x is equal to 0 and x is equal to root 3. So when the limit was x is equal to 0, 0 to the power 2 is 0, so that means t is 0. When x is root 3, square of root 3 is 3, that means the value of t is 3. So the new limits now are 0 to 3 and the function can be written as it is 2x dx equals dt. That means if I put a 2 here and half here, I can do that. So I have half outside and 2x dx gets replaced by dt upon 4 square minus t square. Right? Now this again resembles one of the standard formulas that we have done, integral of 1 upon a square minus x square. So let's just use that formula. So we get half is outside and within the brackets we'll have 1 by 2a. What is a? 4 here. So it is 1 by 2 into 4 and then log of 4 plus t upon 4 minus t. Again this is a standard integral formula that we have done in indefinite integrals. You can go back and watch that video to learn these formulas and see how do we learn them. And the limiting values are 0 to 3. So this entire expression from 0 to 3. So 4 to the 8, because this is a constant I can move it out. 4 to the 8, 8 to the 16. So I have 1 by 16 and I need to put the upper limit and lower limit in this log function. So it is log 4 plus 3 becomes 7, 4 minus 3 is 1, minus replace t with 0 now. Log of 4 plus 0 is 4 and 4 minus 0 is again 4. So this becomes equal to 1 by 16 log 7 minus log 1. Log 1 is 0. So that means the answer is 1 by 16 of log 7. So this is your final answer. Right? Okay, now let's have a look at the last question of this video. If you want, you can pause it and give it a try on your own. Otherwise, let's continue and see how to solve this. Now here, as you can see, we have t cube here in the denominator. Derivative of t cube is 3t square and we have that in the numerator. So that means we can comfortably put t cube as any variable, maybe p. Right? Now 3t square dt will be equal to dp. Okay, we can take any variable, that's okay. So 3t square dt becomes equal to dp and in the denominator we have 1 plus p into 2 plus p. Now what about the limits? When t is equal to 0 and when t is equal to 1, what are the values of p? When t is 0, you put a 0 here, the value of p is 0. When t is 1, put a value of 1, that means the value of p is also 1. So there is no change in the limits in this question, so the limits stay 0 and 1 only. Now such a question, how do we integrate? Recall from the video of indefinite integrals, what is this? What do you see here? It is partial fractions. Yes, because we have two linear factors in the denominator, and if you can understand, both these are two consecutive numbers. So there is just a gap of 1 plus p, and this is 2 plus p. The shortcut for this is, we can just write it as 1 upon 1 plus p minus 1 upon 2 plus p. The smaller of the two factors is the first term, and the bigger of the two factors is the second term. So this is the shortcut for integration by parts, which we have already covered in the video for indefinite integrals. Again, go through that video if you are still not clear with the concept of indefinite integrals. Right? So that means now we need to integrate this function from 0 to 1. It is not yet integrated, so we need to integrate these two terms from 0 to 1. What is integral of 1 upon 1 plus p? It is log of 1 plus p. And integral of this is log of 2 plus p. Now put the limiting values, that is 0 to 1. So if I replace p by 1, it becomes log of 2 minus log of 2 plus 1 becomes log 3 minus log 3. Now minus and then replace p with 0 now. 1 plus 0 becomes log 1 minus log of 2 plus 0 is log 2. I hope it's clear now, right? Let's open this bracket and simplify. The final step is log 2 minus log 3 minus log 1. Log 1 is anyway 0, so we can just remove that. And we have minus into minus plus log 2. So because there is plus and minus, using the properties of log, we can write this as log of 2 upon 3 into 2. So that means log of 4 by 3 is the final answer. I hope you understood this question. So this was the last question of this video. If you found the video useful, please do not forget to like the button, press the like button and share the video with your friends who are still struggling with integration. Subscribe to Boundless Maths if you have still not done it, and click on the bell icon to keep getting notifications for further updates or further videos that can help you in your journey for grade 12. Thank you for watching. Keep learning, keep growing.